Yeah, can you see my screen?
Yes, I can.
Okay, okay, sure. So, your first question is how do we fix memory leak issues, right? So, basically, there were like several tools to identify the memory leak. So, memory leaks is something like if an object is getting created and if it does not get killed or if it does not been removed from the memory, so automatically it keeps on adding to the memory, and it actually wastes, or I would say like it rather underutilizes the actual memory because they were like being used by the old generation or old generation data. So that's the reason we used to get this
Yeah.
memory leak. So this is not something like leaking out of the system. This is something like instead of the new objects that is getting that is using the memory, instead the old objects are using these memory. So there won't be any uh, space for the new object to
Right.
get create or the new object to get its access or its own location to process anything. So that's the reason we used to get memory leaks. And in because of this, what happens is we all know the performance, the response times will be more higher. It will like keep on spiking at some point of time. And at one point of time, what happens is like we used to get the world stop, something like the entire memory
Right.
will start to get cleared out, and uh, then we used to again start from that. So that processing time will actually take some time, right? So even though we have a good network or a good set of cloud architecture, everything is there, but still if there is this kind of memory leak, and these things will happen if there is no proper code. So and we have
Yeah.
actually several tools to find this. Like if we are using Linux, we can use Valgrind. It's actually a programming tool for memory debugging and for any memory leak detection. And if it is like Windows, we can use Visual Studio
Yeah.
Profiler, where for .NET applications, it's very useful for us to find the memory leaks. And it's actually again the main advantage is like it's a built-in tool of Visual Studio. And if it's a Mac
Okay.
OS, we have
Mm.
instruments, which is actually what we have for Windows. We have Visual Studio. So same thing for Mac OS. We have the instruments, which is like part of Xcode, where we can track the memory leaks in iOS or any Mac OS applications. And that's again another reason where we used to see better performance in terms of Mac OS, since they have it as a part of their setup, as part of their Xcode. And the other one is the MAT. So we all know the memory analyzer tool. So
Yes.
it's an Eclipse based tool. So we can use all these tools. So basically, when it comes to analysis part, we can do it in two ways. Like either we can do it through the manual code review. So if we have to like go through the code to identify the places where the memory is allocated, but it's not freed. So we can either do
Yeah.
that, or else we can do the garbage collection log. So where we collect the garbage collection
Okay.
logs, and then we can analyze the values and the results, like what's happening and why the objects are not being collected. So
Okay.
some of the
So,
common, yeah, go ahead, yeah,
yeah,
please.
sorry. I was asking, like, if I have MAT, then what will be my approach towards finding the memory leak? Because I'll see
Uh,
the objects are there. Means
mm, mm,
the I'll sort it with the retained heap. So I'll see that these objects are consuming the
mm, mm.
memory, and if they are cleared, the again the memory will be retained, right?
Yeah,
So
true.
this is how the approach would be, or we'll have some more things to consider.
Okay, so since you said math, I'll go through that way. So if you have math, so the first
Yeah.
part is to understand what is happening. So we have to generate a heap dump.
Yes.
So
Right.
only in the heap dump we could see what is happening, or like what kind of logs will the logs basically will tell us like what's happening. So we all know how to do that to trigger
Yeah.
the heap dump. And yeah, so once we do that, we can load it to the tool. And then so basically we have to see what are the overview. So basically like, we can separate this into two separate analysis modes. So one is the overview mode and the other one is the leak suspects. So when we go to the
Yeah.
overview mode, we can generate the overview report where we can check for any obvious suspects. Like for example, if some object, like as I said in the beginning, like there are like old objects and new objects, and then we have the old and the
Right.
Eden object, and then we have some. They have always the segmentations where they send all their
Right.
old to the place where they used to erase it, right? So we have to find that, like what are the objects that we suspect that it is consuming a large portion of memory. So that's the first part. That's the overview we can find it, and then when it comes to the second part, which is the leak suspect, so we have to click on the leak suspect report, and mat will actually analyze the heap dump, and it will provide a report with what are the potential memory leaks. So basically mat in terms of finding the memory leak, so basically it's a memory analyzer tool. So uh,
Yeah.
with this leak suspect, actually we can easily investigate like what is happening, and it in fact will even provide us a report that what exactly is happening and why is it failing.
Right. So even in the stack frame, we can see
Yeah.
that because of these objects, the memory is getting consumed to
Yes.
this level.
And
Okay.
in fact, in the leaks aspects, again, we have this dominators tree. So if we open
Yes.
the,
Right.
I mean, the mat tool, we can see the dominators tree where we can see like which objects are retaining the most memory. Like if you go to the
Yes.
Java, I think the Java, I don't currently have it installed, but if I have it, I would have shown you. But yeah, if you go to
Yeah.
the Java basics and then if you open the dominator tree, we can see like which objects are retaining the most memory. So once we
Right.
found out that, then yeah, it's so far it's going to be the cakewalk. Like we can tell them tell it
Right.
to the development team that see this particular object is taking more time, come on, you have to fix this part, right? And there
Yeah.
is another way, so we can also do it through the paths to the GC root. So for any suspicious objects,
Yeah.
so if we right click on that particular path to GC roots, and we can see like why this object is not being garbage collected. So there are like different ways. Again, like the first way is dominator tree, which we saw, and then the second way
Yes.
is this path to the GC root. So if we click on,
Right.
keep on clicking the plus symbol, I think if we keep on clicking that, we can find that which is the weak reference or what exactly has happened as part
Yeah.
of this memory. Like what exactly is happening with that object. So basically, the object is the culprit. So we have to find who
Right.
exactly is
Right.
creating all issues. Right? And
True.
then when it comes to the object details, so if you want to find any object's details, so we can double click on that object and see what the
Yeah.
detailed information, like what classes it has, what are the references, and what is its retained heap size. So if it is retaining huge amount of heap
Yeah.
size, then yeah, so there is some issues that's been happening.
Right.
Yeah, so these are some
Okay.
of the ways we can investigate the leak suspect. So, like I said, if we just I'm doing a quick recap. So once we have our
Yeah.
mat, so we can create a heap dump, and then we can load the heap dump, and then we can analyze the heap dump using the overview and the analysis. I mean, analysis in the leak suspects, and then we can
Yeah.
investigate it the dominators tree, or we can investigate it through the path to the GC roots, or even through the object data. So these are some of the ways like we can uh, just narrow down what towards the issue. So once you have
Right.
narrowed down, then yeah, almost we can fix it. And yeah, so
Yeah.
this is one simple thing. Maybe if I would have been prepared, I would have been showed you some examples. But yeah, I'll just prepare some
Yeah.
videos on that, like, some real time examples on
Sure.
that. So
Yeah.
we have- yeah, and then the next one. So if you see all the queries in the DB, let me just copy it in Notepad. So these things will happen. Like for example, we normally have this Oracle AWR reports, right? And that AWR
Yes.
report will tell us which database, I mean, like which query is taking more time in the database. Even it can just tell us in the order, like which is the top 5 queries is taking more time.
Right.
So yeah, there
Yeah.
are like ways to create it. But uh, what could be the reason? Okay, maybe like I think you even in you message me in the chat that
Yeah.
if we say that we have not done indexing, then they might ask you a question like, "What is indexing and what kind of techniques you have to fix it?" Yeah, that's another question which I just take you through. But before that, like, uh, okay. So the first thing is when it comes to the indexing part. So since you asked that question, I'll tell you.
Yeah.
Uh, so we'll be if we do not properly index it, so when it comes to properly not indexing, so what can be the solution for that is like we have to use the var class. So for example, if we use a var class like var city equal to Mumbai or something like that, so
Yeah.
we can only filter those data. But if we haven't add those data, right, var city equal to with some classes,
Right.
automatically what happens is we are going to traverse to the entire database, right? So that is
Yeah.
one way where we can do the indexing, and then by doing join, so it can be using your left join, or it can be right join or left inner join or whatever joins. So you have to use these classes in the right place. So you cannot use var classes in any place or with any other keywords. So using of var class or using of these join conditions can be like it has to be in a suitable position, or it has to be in a suitable place where you're going to optimize your data which you are going to retrieve, like which you're going to take. Because we all know the production database might have like millions of data, and when we are
Right.
taking the data, we have to filter it in the maximum amount so that we just have to take only the required amount of data. And it, in fact, it saves time, right? So once you get the data, automatically it is just going to send it back to the app, and then the app will send it back to the web, and you're going to present it, right? So these
Yes.
are the ways you have to, we can actually reduce the time. And then by using order by, and then also by using group by. So by using order by and group by, yeah, you can very well uh, filter the data which you're going to extract from the database.
Okay.
And yeah, so that's one thing. So where you can use the indexing, you can fix the indexing issues. Yeah, yeah, go ahead.
Okay. So there's also question like, how did you figure out that indexing is needed, or what kind of indexing would you uh, suggest, and why one indexing over the other, like types of indexing.
Hmm, hmm,
So
hmm.
why would not this indexing or not that indexing? So how will you
Okay.
means come to that
Yeah.
conclusion?
So the moment we run this AWR report or any report, or if we even go drill down to the last transaction, we can find which query is being used for that, right? So once you run that query
Mhm.
automatically, most of them like will be like a select query or something like that, right? So once you run that
Right.
query, you can automatically find how much time does it take, and then
Right.
you have to think, or you have to think whether do we need all those data to that particular transaction, or is that going to be a place where we can use this var class. Again, that's what I'm saying. We have to use this var class, or we have to use this joins. Because if we use a, a improper join, like instead of a left join, if we use a right join, automatically we can get the data, but we are not sure whether we are getting only the exact amount of data, or whether we are getting the exact set of data which we need, right? Because if we are using a join in a way that something like, for example, in a scenario, I would say, if you are using a join where you have to take the staff IDs and then their address, right? And there the requirement is you have to take the name, staff ID, and the city. But in the other case, what happens is like you're taking along with the address. So there are scenarios where you can use the joins in a proper way, where you're going to extract only the right amount of data. So the point here is it's not about the query is failing, the query works, but the problem is it takes more
Yeah.
time. And the reason it takes more time is because it's taking some unwanted data, it's taking some more amount of data, which is not exactly relevant for the query, or which is not
Yeah.
exactly is relevant for the application. So the point here is we have to actually manually go through the code. I mean, like it's not again manual, but again you have to run the query and see what are all the columns you're getting, and then you have to just go through.
Yeah.
I'm just giving an example. So but in the real world you might be getting some 10 to 50 columns, right? And then you have to
Right.
go through all those columns, or at least 20 to 25 columns, because when you are accessing some different applications, you'll be getting in terms of ETL application, right? So you'll get the product ID, the SKU ID, its price, its distribution, who is the seller. So you might be getting lots of data, right? So in those scenarios you have to check, because not every data will be in the presentation layer, in the screen, but you're still
Yeah.
getting it. Because you'll be using multiple unions, or you'll be using multiple keywords, some primary thing you have to connect it, right? So the way here is, when you're connecting the primary keys, when you're joining the primary keys, you have to be very careful in adding the joins. So in several scenarios I had this situation, like instead of a simple inner join, if I was using a left join, or some outer join, or some right join, right? So automatically the amount of data which I'm getting is more, and also it in turn it takes a lot of time. So all these things it comes in practice, and then you have to uh, check the requirement and the actual amount of data you're getting, or the actual amount of columns you're getting.
Okay. So if it's like a million, sorry, million rows
Hmm, hmm,
on database, and even the columns are like maybe in hundreds, then it's very difficult to get into the details and find out. So on a higher level, like if I'm a like normal performance engineer, I have
hmm,
access to Dynatrace, and I
hmm,
see
hmm,
that
hmm,
this query is taking the highest time.
hmm,
I
hmm,
filtered out the
hmm,
one which is like I saw based on the response time.
hmm.
Now my course of actions will be to do the optimization of my
Yeah,
query, right?
yeah.
To, yeah. So how like what will be my further steps?
Okay, so you're asking like how can I optimize this query?
Yeah.
Okay, okay. uh, so the first thing is you have to break the logic. So you have to like because when it comes to databases, like it has to be the query. So if there is some
Yeah.
inefficient query, so the first thing is we have to simplify the complex logics, and then we have to break down the large queries into smaller ones, and even we can use like subqueries, or we can use common table expression. So by doing all these, we can break it to a simple way so that we can get only the exact or I would say like the optimized results. That's one way to reduce the response times, or uh, improve the performance in terms of your queries.
Okay.
Yeah. Apart from
And
that,
regarding the index, sorry, I couldn't get it. Like,
mhm.
on what basis will suggest indexing, and why? What kind of indexing, and why one type of indexing over the other?
Mm, mm. Okay. So first thing, we have to monitor the query performance, which I think we can use it through the database monitoring tools. For example, like you have the performance schema if you have MySQL, or you have PG statements for PostgreSQL. So by using these tools, we can identify the slow running queries, even if because most of the times the
Mm.
Oracle only supports the AWR reports. But when it comes to the other databases, like for example for SQL, MySQL, or for SQL Server Profiler, you have the performance schema. And for PostgreSQL, you have the PG statements where you can identify these slow running queries. And then the next thing is like when it comes to analysis, so you have to run the explain command so that you can see how does it work. And then you have to
Sorry,
find the
schema.
bottlenecks. Yeah.
Again.
So yeah, you have to find the bottlenecks, right? So once you find the bottlenecks, you have to identify the columns for indexing, because you cannot add columns, you cannot add indexing to any columns,
Right.
right? So you have to identify the columns. That's the thing I'm saying again. So once you identify the columns, you have to use uh, for example, you have to find where you can use the var class, or you have to find the columns where you can use the joint conditions, and the order by class or the group by class. So the point here is, first thing is like you have to identify the queries uh, which is taking more time, and then you have to identify which columns you're going to index. So indexing is something
Yeah.
like you're going to tell that, see, these are some of the common queries which has been taking more time, which has been called all the time. So you're going to add an index so that they'll be like again I would say like you can add the var classes in the columns which are frequently used, right? So when you add the
Mhm.
var class in the columns which are frequently used, automatically what happens is you'll get that data very quick.
Yeah.
Okay. And then you can add the columns in which are used in the join conditions as well.
Yeah.
So basically our tuning is going to be in terms of the columns. So you're going to use the columns, the var class in the columns which are frequently used, and then the columns used in the join conditions, and then the columns used in order by or group by classes, or the columns that appear in high frequency queries. So these are the columns which you are going to identify. We are going to use for indexing. So indexing is not something like you're going to index the entire table. So indexing is something like you're
Right.
going to index only the columns, right? So again, the columns are frequently called. So for
Okay.
example, if one particular column has been multiple times, it's been called multiple times, so we have to add the var classes or the joins it for that particular column so that they'll be like more quicker.
Yeah. So indexing is like how we have in the books that this page is for this chapter. Similarly, on those lines only.
Yeah, exactly. So, for example, in the book, yeah, we have the index, right? So, if
Right.
I want to go to a particular for part, like for example, like JMeter indexing or like some jQuery indexing, it's in the page number 44. So I can very well see it's in the page number 44. So I just go there. So I
Mm.
can just show you. I can just type and show you just one of the example. This is a way where you can create an index. So it's an example here. Um, uh, it's like actually create. Can you see the
Yes.
letters, right?
Yes.
Okay, I can just maximize it for you. So this is one way where you can create an index or index, and then you can give an ID. So something like an index ID um, on on the table, or like I can give you like orders. And in this, I'm going to index for the column, which is customer ID. So you're going to create an index uh, on this particular okay, you're going to create an index with this particular name. So this is the name of the index, which is index ID, and then it is going to be in the table, and here is the column name. So this is one example where you can create the necessary indexes.
Okay.
So once you create the index and after you rerun the query, you can compare the performance, like how does it work before and then how does it work again after this query.
Yeah.
So by
Right.
doing this, you can improve the performance because you're going to tell that, okay, so this particular column is being used or called multiple times. So I just want to index it.
Yeah.
So the next time, automatically, if someone calls the customer ID, it will be automatically called because you have created an index.
Right. So I have a cross question as well. So
Yes,
in
yes.
what cases
Mm,
we should go with indexing, and in which cases we shouldn't go with indexing? So this was also one of the
uh,
interview questions.
okay. Uh, okay. So the first thing is, let me just type it here. So the first thing is like the frequently queried columns. So you are querying a particular column multiple times, or you are querying multiple columns frequently, often, like more often than any other columns. So that is
Yeah.
one column you have to add the indexing. So in our example, like it's customer ID. So customer ID is something like which is being frequently used. So we are going to add indexing to that particular column,
Yeah.
right? And then the next thing is like the join condition. So previously we said this query thing, and then when it comes to the join conditions, let me just type it. So you have to use, for example, like, okay, uh, column used in join conditions to speed up joining tables. For example, we have this in customer ID here, right? And then this customer ID will be in two different tables because they are primarily the primary key. Okay, so
Yeah.
when you are joining, you have to use the like, for example, what I say, like column, not to say like that. So this customer ID, let me just draft it quickly. This customer ID will be in both orders and customers table, right? So in that scenario, you have to create an index like the same way. Let me just copy this here. Uh, yes, on orders customer ID, and then you'll have this same customer ID in this customers table as well, right? So these are two tables. So one is orders table and the other one is the customers table. So you are going to create the index in both the tables. I mean, for both the tables. Again, it's going to be for the customer ID. So for the orders table,
Right.
you're going to create, and then you're going to use it for the customers as well. So in this scenario, what happens is you are going to get this value very easily because you already have an indexing. Like if you go to the orders table
Yeah.
also, you can get it very easily, and then when it comes to the customers also, you're going to get it very easily. And then when you are joining it, it will be more easy because anyways you already indexed it,
Yeah.
right? And then the third one is you can do it through ordering and grouping. So we all know the order thing where we can use order date. So for example, if we
Right.
want to order the um, uh, what to say, the list of orders, so we can order them in a way that
Ascending or
in
descending
ascending order,
order.
descending order, so that we can get
Yeah.
in that order. So even that also will help us. So
Yeah.
for example, let me just give example here. So we can create an index. I would say like order date. Just okay, index underscore order date on the table. You can say orders. The same table, I can just copy it here. So in the table orders, and can be order date. So these are some of the examples. Okay, the firstly,
Yeah.
you can add indexing to the frequently queried columns, which is in this example, it's customer ID. And then again, if we are using multiple tables, again, you can find which particular column is being frequently used, and we are going to create indexing for them in both the tables. And then again, in terms of ordering and grouping, yeah, you can create index for that particular uh, column, which is again like in terms of ordering and grouping, right?
Okay. And in which case to go with indexing, and in which case not to go?
Not to go indexing, yeah.
Indexing.
If you are not, if some value is not being frequently called, like for example, customer ID is being frequently called, but his city or if his other details, which is like the nth data, like 20th data, 25th data, like something like his his background details. For example, I'm telling you, if a customer
Yeah.
ID has been taken, so his customer orders or his um, phone number can be is required for us, for a seller or for someone who is really needing to talk to him. But something like which is not completely relevant to his data, but it's again part of his database, which is part of his table, is not required. Like, so mostly, uh, I would
Means
say,
from
yeah.
the performance perspective, even if we have some unnecessary indexing, what will
Yeah.
be
So the
consequences?
thing is, yeah. So what happens is, like, when you have multiple indexing, what happens is every time when the database kicks in, automatically it goes through all the indexing first. So that will actually
Oh,
take a lot of time, because
okay.
before it even kicks into the databases, it will actually go through, it scans all the indexing. So it's always good to optimize the indexing as well. And again, you have to, there's another thing, because you have to again rebuild your indexing every now and then, because once you created it and if you kept it, it doesn't go, it doesn't promise that it is going to work all the time, because every time the application changes, we are bringing in new changes, we are bringing in new releases, right? And the business also changes, the logic also changes. So every frequently, like 3 times, 3 months, or I would say 3 months is maximum, because nowadays, like, we are doing releases every week. So every 3 months or like every 2 months, we should walk through the indexes what we created, and we have to again check whether it's been working properly, or if it is not, then we have to rebuild it. Like, for example, if it is like customer ID, maybe at some point of time a different column could be a frequently called indexing, right? So in that
Yeah.
scenario, we have to change the indexes, we have to rebuild it, we have to alter it,
Okay.
right? So these are some scenarios where you have to keep on updating the indexing as well. And like I said, yeah, so you have to optimize the indexing as well. You should not see indexing, again, we all know it reduces the amount of time, but that doesn't mean that we have to create indexes for everything, because if you keep on creating
Yeah.
indexes, then processing that will take a lot of time,
Right.
right? So in
Yeah.
that scenario, we have to completely remove it. Like, I wouldn't
It
say
will
completely remove,
be.
but yeah,
Yeah.
yeah, we have to be very careful in creating the indexes as well, because in most of the
Right.
scenarios, in most of the organizations, they will not even agree that creating an index is a long-term solution.
Yeah. Means it should be done wisely.
Yeah, exactly. So it should be done wisely, and it should be monitored again. It should be monitored very
Yeah.
frequently, so that your performance is also increased, and you're not going to create more load to your databases.
Okay.
Yeah.
And what kind of indexing are there? And
Okay.
like that question is.
Uh, Actually, there are like a lot of indexes, I would say. Like, let me just take you through
Yeah.
some of frequently used. So we have single column indexing. So this is something like this one, the one that we have created here, right? So just creating
Yeah.
an index for one particular column, and this is like efficient if you are using it based on a single column, instead of, like, again we have like composite indexing as well, where we can create indexing for multiple columns. So this is something, yeah, composite index, yeah, I remember. And then you can create multiple, sorry, it's multi column indexing, um, where you can, this can be useful for queries which are filtered based on multiple columns, so particularly when those columns are used together. For example, like, if you have a customer ID and his details, like his order details, so instead of having it as a single uh, column, like, for example, like, okay,
Yeah.
see, there were scenarios, okay, so you can't expect every time to use multi-column index. Sometimes you would need only to use only the single columns, but in some scenarios like this, like customer ID and order details, yeah, you would definitely need to bring more, so that what happens is, the moment you search, automatically only those data will be like picked up very quickly, because already you're going to index, already you have indexed it. So those details
Yeah.
with that particular customer ID and the order details will be like very quicker. And then we have this unique indexing. So this will ensure that all the values in the index columns are unique, rather than like duplicated, or you're going to create a unique kind of results, right? And I think, let me bring back.
Sorry, I didn't get this.
Yeah,
Means
so unique, we all know, right? The way to,
yeah.
you don't bring duplicates. So when
Yeah.
you are
Yeah.
avoiding duplicates, automatically you are going to bring down your
Okay.
results to half of what you want. Like,
Okay.
for example, if you are um, going into an application where there is like the first name and last name are same, and there will be like duplicates, which is like I would say okay, most of the times when we do join, right, what happens is we'll be getting a same set of data multiple times, because when we are doing a join, what happens is like there'll be like duplications. So when you are creating unique indexes, what happens is they avoid bringing duplications. So you're bringing like unique value to the columns, or you're going to just extract only the unique values. That's it. So unique is something like you're avoiding the duplication.
Avoiding
That's
all
it.
the duplicates. Yeah.
Duplications, yeah.
Right.
And then we can create full text index. Okay, I think this should be the unique one. Okay, it should be like create unique index, yeah, and then index ID. So the format is going to be the same thing, unique index ID on. Let me use the same table here on this thing. Yeah. So the only difference is you are going to add unique to this. That's it.
Okay.
Uh, so you're going to add uniques to the unique to this particular index. So if you add that, like I said, you're going to bring
Right.
like you're going to enforce unique constraints on the columns. That's it. Nothing
Okay.
else. So this will again avoid duplicates. That's it. So when it comes to full text index, you're going to search. Are you going to index which supports the full text search capabilities? For example, like if you want to search some values within some large text fields, for example, we might be having a feedback thing. So with a feedback which has like some 50 words or 30 words. So okay, do you remember we have this Google Maps, right? We
Yes.
all enter the values right there, right? We all enter some our feedback, like I went to a particular restaurant and their service is great, they had a good parking, the price is very less. And if
Yeah.
you see there is this particular thing on the top. If you see let me they will have this texts alone, like service, parking, and
Yes. Yes. Yeah.
mm, price, something like. So if you click on that,
Right.
automatically it will take you to that particular comments alone. So that's a
Yeah.
perfect example of this full text index. So because you're indexing only the particular value from the full text, you are not. Okay, let me. If you remember, I'm not. It's good, but still, I think that was one interesting thing which I usually see in the Google Maps.
Yeah.
Uh,
Yeah. I got
yeah.
that.
You remember that, right?
There are
Yeah.
something like stars, and we can directly just
Yeah.
check it.
So
Yeah.
let me just take it, because that's one interesting thing I usually watch
Okay.
in the because I was previously Google. I was like uploading photos for the Google Maps thing. So
Okay.
that was one interesting thing I used to do. Let me just take it. I'll just show you. It's quite interesting here. Yeah. So if just taking some random examples. So if you go here and where is that reviews? Sorry, yeah, here. If we go here and oh, sorry, my bad. Um, so if I just want to like, search for service, so it'll just give only for the service thing. So can you see here, right? The service is
Yes.
highlighted. There's
Yes.
something like this we used to get. So this is something like a full text index. So even though I have a full text, like a big text, I could take
Right.
whatever I need. So this is another way of indexing, right?
Yes.
And yeah, so these are some of the ways we can do the index. So it all depends on what is going to be your requirement. So if you are trying to scrutinize, or if you're going to optimize a particular column, which is exactly, because again these changes, because we all work on different set of applications and we have like byproducts to it. So everything is different. So we have to first think like what exactly are we going to optimize, or what exactly are we going to filter, or we're going to take out of the result. So based on that, we have to build our indexing. And then
Okay.
I remember spatial index. Yep. So yeah, I believe like I think by giving all these five examples, I think they
Yeah.
would be having some better idea. And yeah, spatial is something like a geographical information system, the GIS thing. So if we have any location based, for example, like if you use any applications like Zomato or any nowadays, like every apps is
Right.
using our locations, right? So anything which is useful for geographical information systems like GIS, like I said. So this spatial index is used for that. So, but I would
Okay.
say in the uh, what to say, in the ideological situation, like the most of the times the I would say like uh, the top applications we use, they normally come with these top four indexing. So the single
Yeah.
column index, and the composite where you have multiple columns, and then the unique index where you have to have some unique values to index it, and then the full text, like I said, an example of the Google Maps where you can filter your indexing in from a full set of
Right.
descriptions, right?
Yeah. So even in my project, it is a single column index that
Mm,
we had
mm.
used.
But yeah, again, I would say it's a best practice. I can even you can tell this in an interview as well. Even though if you haven't done that, you can tell them that you frequently did a walkthrough to the indexes, and you check on indexes whether it's again can be a single indexing, or in terms you did an analysis where you can add as a or change it to a multi-column indexing, right? So you can even tell them that you did a walkthrough, or you can do the analysis, right? That's our point. We can do it proactively, and we can make changes to it. But I know, I agree that we, as a performance testers, we do not have more access to the databases or to the
Right.
code. But still, I think I remember we have access at least in the lower environment, like the dev environment or in the database in the dev, right? So at least we can give some suggestions, because if they really want to add some value to the application, yes, they really have to open the doors to the performance engineers.
Right. Right.
Yeah,
Absolutely. And
yeah.
so,
Mm,
like in my project, it's Postgres DB,
mm, mm,
and for checking the queries, we have Dynatrace. So
mm,
it
mm,
gives
mm,
a very clear picture that this query is taking the longest because we can directly filter and see. Even we get the whole query.
mm,
Now it's like after I have the query,
mm.
what all tools or what can I use to further check? Like how can I optimize it?
Okay, okay. Ah. So you're telling that you have found all those queries, like the most
Right.
frequent or the costliest queries in the data trace, but still you have
Right.
to optimize that. Okay, got it, got
Yeah.
it. So you're asking how can I still identify, or what are the techniques I can
No,
use?
no. So how can I further optimize it?
Mm,
Means
mm, mm, mm,
I have the query in hand. Now
mm.
all I have to do is optimize it.
Optimize. Okay, got it.
Yeah.
So the first thing is, like I said, you have to use proper indexing. So which is you have to go through the indexes and check whether they really add value uh, uh, to your performance, right? So for that, I think you can use explain to understand the query executions, like how do they really work. So if you use explain, you can see whether that particular index works fine, or like what exactly is it doing. And then I'm not sure whether we have access to it, but still I would recommend you to rewrite the queries where you can um, rewrite your select queries. So most of the times we used to get the request rather than updating it, because once we select the request, we do the update is like very less, or like the update or the insert. I would say the post data are very less, but still the get requests are more, right? So we have to avoid all the unnecessary columns to be transferred. I mean, the data transfer has to be like very less. So let me just write it down.
I mean, okay, I have the query. It's a complex query.
Ah,
Maybe 5, 10 lines query is there.
okay.
Then, as a performance
Mm-hmm,
engineer,
mm-hmm, mm-hmm,
I might not be very good with the SQL or with the queries.
mm-hmm.
So, is there any tool or is there any like a skill profiler which I can use?
Mm. Yeah, so see, the only thing is like you have to understand the query. So that is mandatory, because without understanding what exactly is it doing, because I know like select query, if you run it, it will automatically bring the results to you, right? So when you see the results automatically, you can understand what are the results it's picking up and why is it picking up. Because if you add the conditions, you can very well know. Like for example, you have a query like select the customer ID or the order date uh, for a particular customer ID. You can find what are the details it's bringing, right? And then you have to check whether you're getting only the required columns or not. So see, when it comes to tools, uh, okay, again, there were some tools like even again they say like they monitor the queries and they can give you an insight. So for example, you have SolarWinds database performance analyzer, and it supports PostgreSQL. Maybe you can use that, because that will again help you to monitor the database performance. It can help you to identify the slow queries, and it even gives you recommendations. Let me just
Okay.
check. SolarWinds database. Yep. Yeah. So this tool, I think this even supports the PostgreSQL, and
Okay.
this can help you for monitoring, analysis, and tuning. Yeah, maybe you can use this tool. And yeah, so this is one tool. I think this is the one that supports PostgreSQL. I think is there any other tools to support Postgre? No. Yeah, this supports PostgreSQL. I think there are other tools, but they support other tools like MySQL or MariaDB. Uh,
Okay.
you can use PG admin. Let me check whether it's there. PG admin for Postgre. Yeah, we have PG admin. Where is it? Yeah, yeah, you can use this tool as well, and they help you to. I guess not this one, but yeah, I can just check. I think
Yeah, maybe
this
you
one,
can
yeah,
check
PG admin.
later.
But yeah, but for now, I think SolarWinds database performance analyzer actually it gives you a. But again, it comes at a bit pricey.
Yeah.
So yeah, it's a kind of pay tool, but in terms of your query performance analysis, yeah, this will help you very well. So maybe you can,
Okay.
I would say, like you can recommend this. And again, they said machine learning things, this, that, all the jargons to sell their items. Yeah, but still, I
Yeah.
would say, yeah, maybe you can try using this tool, and this will definitely help you to optimize your queries.
Okay.
Okay, and then yeah, any other questions for now you have, or
No, I'm good now.
sure. So yep, let me come back. So any other doubts in this indexing part, or
No.
you're fine? Okay,
Yeah.
sure. Then what I'll do is let me take some time, and then I'll prepare videos on your questions. And if you have anything, just let me know. We'll do a quick catch up for anytime.
Sure, sure.
Yeah,
Yeah.
sure. And you're joining the boot camp tomorrow, or you're
So it's Neo load, right?
it's with Apache JMeter and Azure DevOps. Neuro, I think we had last week.
Oh, okay, okay. Sorry. I think, yeah, yeah, I'll join them.
Yeah,
I
sure.
thought it's a Neo load.
No, Neolord we had last week, so this week we are
Okay.
that's completed. Yeah, but yeah, we will just have multiple boot camps, no problem. Anyways, every time we discuss it, we are going to come up with new ideas. So no worries.
Yeah. And they're really good, your videos.
Oh,
So keep making them more like,
yeah, sure.
yeah,
Thank you so much.
they're very helpful. Thanks.
Thank you so much. Yeah, it's nice
So
talking to you.
should we
Yeah,
wrap up today or you
yeah, we
can
can
go
wrap
ahead?
up today. If you have any questions, you can just let me know. We can discuss in our next catch up.
Sure.
And meanwhile, like I'll just go through all your questions and we'll prepare some video on that.
Yeah. Or
And
maybe what I can do, so I've like mixed all the questions. I can segregate based on CPU, memory
hmm,
disk,
hmm,
that way also,
hmm.
so that all the DB related questions will be covered or the
Yeah,
CPU
yeah.
related questions will be covered. That would like because there would be some linkage if
Hmm,
I
hmm,
talk
hmm.
about memory, then GC, all those things, like hidden, uh, I mean, the young generation, old generation, all those things
Yeah,
will come in all the cases, most of the
true, true,
cases.
true.
So, yeah. So better to like have all of them at one place and then we
Yeah,
can do. Yeah.
sure, sure.
Okay,